we are going to see a problem whose energy and power we need to calculate in order to decide what type of signal it is. And this exercise we are going to apply for a continuous time trigonometric function. So signal x of t equal to 4 sin t. As we know, sin t will have the curve like this. Since the amplitude is 4, the complete plot of x of t against t will be like this. So for this signal, we are going to find out energy and power. So the energy of signal is given by E infinity equals integral minus infinity to infinity x square t dt. There is no standard function given like a step which will restrict signal taken from 0 to infinity. Hence, we cannot change the limit, meaning this x of t exists even in the negative part of the t. It is something like this. So 4 sin t square dt. 4 square is 16 can be come out of the integral. So in integral it is sin square t dt. I cannot directly solve for a sin square. I need to convert that into a first degree of a trigonometric function. Meaning, if I use the formula sin square theta equal to 1 minus cos 2 theta upon 2, then second degree of trigonometric function converted into first degree. If I do that, I will get E infinity as 16 integral minus infinity to infinity 1 minus cos 2 theta upon 2 d theta. So here, instead of a t, I have taken theta, one and the same thing because it's a definite integral. So in next step, maybe I will take instead of theta as t. So if you solve, I will get 1 by 2 outside and inside integral it is 1 minus cos 2t into dt. Remember, here I have taken a theta and that theta I renamed as t once again. In definite integrals, it is not going to matter. So in the end, I will get this expression whose integral will be t minus sin 2t upon 2 limit minus infinity to infinity. So E infinity equals 8. Let's apply the limit, upper limit, infinity minus sin 2 into infinity is infinity only, minus infinity. Since there is a sign term and sin of minus infinity will become sin repeat. Sin of minus infinity is minus sin infinity, hence there will be the change in the sign. After solving this, I will get infinity minus sine infinity by 2 plus infinity minus sine infinity by 2. Now here we need to find out what exactly this value will be. So you must be thinking infinity is there, one more infinity is there, so it becomes 2 infinity. Hold on, that is not the case. Whenever infinity comes for a calculation, it always gives you answer infinity. That means if a number is not defined, how come we define the operations on that number? Meaning infinity plus infinity in the end will be infinity only. Now the question is, what about these two terms? Whether that is infinity or not? The answer is sine infinity cannot be infinity, just like sine 0 is 0. Why? Because sinusoidal terms will have values ranging from -1 to 1. What is the meaning of this? Any sinusoidal term or sine of any angle will always have minimum value -1 or maximum value 1. Sine cannot have values beyond this range. So in any case, for any angle, be it infinity, I cannot have sine term more than 1 and it cannot be less than -1. In the end, these two will always give you finite numbers. So these are the finite numbers, but whole term will be infinite because of these two infinite numbers. So in the end, I will have E infinity as infinity. Pertaining to this, I can say given signal is not an energy signal. That is for sure. So once the energy is infinite, our next step is to find out power. So let's find out the power of a signal. P infinity equals limit t tending to infinity 1 upon 2t integral minus t to t h square t dt. So P infinity equals limit t tending to infinity 1 upon 2t minus t to t 4 sin t square dt. So this will give you constant 4 square, which is 16, can be come out of the integral. That is that limit t tend to infinity 16 upon 2t, and here also I am getting a sin square t, which can be represented as 1 minus cos 2t upon 2. This is just similar to the way we have done for the energy. So over here 2 is getting cancelled, which will give you 8 upon t, and 2 is also coming out. So basically it is 8 upon 2t, and integral of 1 will be t cos 2t is sin 2t by 2, and the limits are minus t to t. So one more time, 2 is getting cancelled, giving 4 upon t, and let's apply the limit. Upper limit is t minus sine 2t by t, repeat 2t by 2, and lower limit will give you minus t plus sine 2t by 2. Further, it will be p infinity equals limit t tending to infinity 4 by t, t minus sine 2t by 2 plus t minus sine 2t by 2. If I solve this, I will get t infinity as limit t tending to infinity 4 by t, t plus t is 2t, and 2 times this term will give you sine 2t. Next step, we are going to apply the limit individual terms, meaning it will be limit t tending to infinity 4t multiplied by 2t minus limit t tending to infinity 4 by t multiplied by sine 2t. Once again, same concept, we can cancel out this t because t tends to infinity, meaning t not equal to infinity. The finite number can be cancelled out. But over here, there is no such provision. So for this limit, we are straight away applying the limit. It is t tending to infinity. Applying the limit means what? Over here, wherever capital T is there, we will replace it with infinity. So in the end, I will get p infinity at 4 into 2. Over here, it is 8 minus here 4 upon infinity multiplied by sine infinity. Since sine of any angle cannot go to infinity, it will always have some finite number. So finite number divided by infinite. Anything divided by infinite except infinity and 0 will always give you answer 0. So finite number divided by infinity is 0. So I can say p infinity over here is 8 minus 0. In the end, it will be equal to 8. So I'm getting power as a finite number. So since power is a finite number, I can say given signal is power signal. This is the end of a problem. Thank you.